Okay, hello everyone, and welcome back to a new episode of APIM Hotrod. And today we are here with the great Darrel Miller. How are you, Darrel?
I'm doing excellent. How are you, Massimo?
Very good, thank you. Okay, guys, so today with Darrel we talk about OpenAPI specification, client-side SDK generation, and discovery. So all of these nice topics where Darrel is one of the is leading the space, let's say, or one of the in the core, one of the member of the core OpenAPI specification right since years, Darrel. So I would like to start with you from the OpenAPI specification, just like talking about the state of OpenAPI specification and where are we heading.
Yeah, it's quite interesting. We are heading in a bunch of different directions because there has been quite a bit of new energy breathed into the OpenAPI specification group, the working group, over the last probably 6 to 12 months. And so you may have heard about 6 or 8 months ago, we announced the Moonwalk project, which was the plan for the next major version of OpenAPI. So that would be OpenAPI v4. Although we're not 100% sure whether we want to keep the OpenAPI name and the v4 and just completely change to Moonwalk, because people seem to like having fun names to say rather than saying OpenAPI. And especially since OpenAI came around, it's getting really hard to talk about AI-related things, talking about OpenAI and OpenAPI. So we'll see where that goes with Moonwalk. But yeah, we have weekly meetings. Anybody's invited to come along. We run everything off GitHub, and we are laying the foundations for the next major version.
And if you look from the current the V3 V3.01 with V3.1 and the Moonwalk, so the V4, what are the major changes? If we can point out one major changes.
Yeah, there is an effort to flatten the structure. It's a little too nested. It's a bit awkward working with it. And in doing so, we are trying to make it more flexible insofar as there are some APIs you just can't describe with OpenAPI, because when you define a particular endpoint, you can only provide the path. And so you can't just define query parameters. And so if you have two different operations that return quite different results depending on a query parameter, it's quite difficult to do. If you were trying to model some kind of JSON RPC thing where you actually have some element in the body causes the response to be a very different shape, you can't model that either. If you were to model something like a gRPC payload where it's the header that defines the actual shape of the response, you can't do that either. And so we're trying to find a much more flexible way of saying, here's a list of operations, here are the set of characteristics of that operation that define the signature of the operation, and then here are the responses to that operation. And so we're trying to do the impossible in that, making it more flexible and more simple at the same time, with more of a kind of a pattern matching model that allows you to use more of the HTTP request elements as part of the selectioning process. And it will unblock us on a bunch of things. Like at the moment, you can't have optional path parameters. You can't have a parameter that is a multi-segment parameter. So if you're trying to model a folder hierarchy, you can't do it. And we're going to try and move to using full URI templates, the 6570 URI templates, in order to identify an operation. And by using that syntax, we can get rid of some of the complexity in parameters where they have like an explode thing and allow reserve. There's a bunch of things that we invented in 3.0 that modeled itself after 6570 RFC 6570 URI templates, but we didn't actually use RFC 6570 templates. The plan is at the moment to actually use those templates properly and use all of those features, so parameter descriptions can get a little bit simpler.
And tell me if I remember well, when so this show is a lot about lessons learned about API management, so Azure API management.
Mm-hmm.
If I remember well, you were working at API management when OpenAPI was integrated into API management, so, or it was around that time.
It was already in when I joined. I joined as a developer advocate actually initially. And then I transitioned to being a developer on the team between 2016 and 2018. And they did have support for OpenAPI v2, but they didn't for v3. And so I worked on the integration of OpenAPI v3, and that's when we ended up creating the Microsoft OpenAPI.NET library, which now
That's
has...
exactly where I was heading, and I was wondering now with this moonwalk, this V4, how is difficult for a product? I know that is a weird question to intake a new version, like from a V2 to V3 or from V3 to V4. So you think it's a 12 months journey, or is it a challenging task?
Well, so this is the interesting thing about the way the OpenAPI.NET library is built. The OpenAPI.NET library, you could argue, doesn't actually support multiple versions. It only supports the latest version. But what happens is when you read in a V2 document, on reading, it transforms it into an internal V3 representation. So the API management code only deals with the V3 model. And we're currently working on an OpenAPI 3.1 support where we've changed the model again for OpenAPI 3.1. And we will continue reading in OpenAPI v2, OpenAPI v3, and 3.1. It's just that as we read it in, we upcast it into a 3.0 model. So interestingly, if you take the OpenAPI.NET model and you read in a v2 and you write out a v2, in the middle, it's actually treated as a v3. We transform on inbound and we transform on outbound. And what that does is it means that people who are integrating that library into their products, like API management, like Logic Apps, Power Platform, they don't have to worry about supporting multiple versions. If you look in the AI space, Semantic Kernel as well uses the OpenAPI.NET library to read OpenAPI. And so it can support v2 and v3 automatically. And so this is the path that we take. And it means all the work of doing that translation between versions happens in that library, not in the product that actually has to use it.
That's great. That's great. Okay, cool.
That's the theory.
Yeah, you never know, right? Okay. Another thing. So I wanted to ask you is I recently saw a session of you about client SDK generation. I think it was in New York or so. So would you like to tell us something about Kiota and client SDK generation? So what's your opinion on this?
Yeah. So at API Days in New York, I did a session on Kiota. There's actually a whole bunch of sessions out there if you search for Kiota. The beautiful thing about picking Swahili words as a name for a product, they got great SEO. So you really won't bump into too many other things that talk about OpenAPI and Kiota. So we had my team, the team I work on is the Microsoft Graph team. And we own the SDKs for Microsoft Graph. And we were really struggling with keeping those SDKs up to date. They had a bunch of T4 template stuff in there. And every time we had new features, we had to go change the templates for every single language. And it was hard work. And it was also based off of Microsoft Graph actually doesn't use OpenAPI as the API design language. It uses CSDL, the OData design language, and we actually translate CSDL into OpenAPI, which is another piece of tooling that we own. And anyway, it was just a lot of work. And we said, we think we can make life easier by using OpenAPI to generate the SDKs. And we tried using the Microsoft Auto Arrest tool, which a lot of teams, which Azure uses, because we were getting a lot of people saying, "Hey, why don't we just all use the same tool?" And we made a valiant effort to try and use Azure. One of the challenges is Microsoft Graph is really, really big, and the Auto Arrest tooling at the time was not able to deal with the OpenAPI the size that we actually had. And so, and splitting it in Microsoft Graph is hard because we try to be a graph and we connect and we reuse concepts all over the place. And so every time you tried to split it, you ended up pulling in a big chunk of things that a big part of the graph anyway. So we started down this journey of building a new client-side generator. But we know there's a bunch of generators out there, and we didn't want to be yet another generator that was just useful for Microsoft Graph. And so we built something that would work for any OpenAPI description, with the specific goal of trying to build this as a community project that anybody would be able to go and use in order to create SDKs for their API. And we are now generating all of our SDKs for Microsoft Graph using it. But we had some interesting learnings along the way. One of the things is, because Microsoft Graph is such a large API, nobody wants to use all of it. They only want to use some part of it because they're trying to solve some very specific problem. And in order to address that, we kind of came up with this, what we call the self-serve model, where you can actually take our tooling that we use to generate our SDKs and just use it yourself. And the more we thought about that, it was like, this is actually a really nice model, because it now brings the code that is actually making the call to the API into the developer's code base. It's easy to trace through. They own the code. They don't have a dependency on the library. They don't have to wait for us to do a release. They can update it anytime they want, and they can build it to only generate the code for the actual endpoints that they care about. And so rather than us trying to figure out how we could split it up into separate modules to make the size more manageable, we actually built a VS Code extension that allows people to go and point to an open API, say, I care about just this API and just this API, and just generate the code for that. And they get exactly the same experience as if they went and downloaded our packaged APIs, or sorry, packaged SDKs. And the more that we've spent time working on that, the more we think that that is actually a better way of consuming APIs, rather than waiting for an API producer to produce the SDK for that API. Now,
okay, so there are 2 points that I get from this. So one point is that the lessons learned from the Graph team, like, okay, there are a lot of operation. I want to use only 2. Why I need to intake an SDK of, I don't know, 1 gigabyte of things if I can just select these 2 operations and have my little SDK for myself. That's the lesson, let's say, number 1. And the other take from this conversation is just like, it's more like I'm building some software and I have to manage my external dependencies. I don't want to intake all of this external dependency in my code base. I can just generate my SDK for those 3, let's say, dependencies, and having a uniformity in my code base, this consistent experience, let's say.
Yes, and that gets really important when you run into the situation that you're doing some kind of integration work where you're taking data from one API and you're sending it to another one, or you're combining information from 2 different APIs to generate a result, and you pull down the 2 SDKs, and under the covers, one uses Newtonsoft JSON version X and the other one uses Newtonsoft JSON version Y, and you end up with conflicts in the dependencies that people have pulled down. And there is also, if you start to think about the world of secure supply chains, and you're building an enterprise solution, you're going to deploy it onto a service. Every time you pull in an SDK from a third-party vendor, you've just increased your supply chain into their supply chain. Whereas if you have if you're generating the code, you're only taking dependency on that Kiota-based code base. And from an experience perspective, we all have opinions on what is the best way of projecting an HTTP API out into code, and people will go, this is not idiomatic, and this isn't the way that I would do it, and this isn't how I would do auth. And so what, as a consumer, you end up dealing with is, well, that API producer has this set of opinions, and I have to learn how they want me to call an HTTP API. And then this other API producer has a different set of opinions, and it works completely differently. And in this approach, where instead a API consumer chooses the tooling that they want to use in order to consume HTTP APIs, they make one choice, and they learn how to use it once, and now that they can call any API using the same set of conventions.
Yeah, that's great. Yeah. I was thinking like there is always these two sides. Developers are opinionated. I was used years ago to say that SDKs were the developer's painkiller, but sometimes you get this painkiller and you create way more pain. The example of dependencies that you intake and all of these conflicts that you might have. So it's an interesting discussion.
Yeah, I developers, I said in the talk in API days, we all have a tabs versus spaces or curly braces on this line. We all have our opinions on how things should be done, and 50% of devs just will say, no, I don't want to use your SDK. I know how to make an HTTP call. I've learned how to use the library within my platform, how to make it. I don't want to take a dependent and learn how to do it via your set of tooling. And that's valid, but then they need to provide all of the boilerplate stuff, all of the auth stuff, all of the retry handling, all of that kind of stuff. They have to have their own solution for. And it's just a waste of time. We should have one set of tooling that can do anything. And just like, that's the way it works with GraphQL. That's the way it works with gRPC. There's one set of tooling that can call any gRPC API, or a bunch of different options that people can choose for GraphQL to be able to call any GraphQL API. You don't have to go and download the GraphQL SDK. And there's no reason why we can't do the same thing for HTTP.
Yeah, you are back at the wisdom age. No, I'm just having fun.
But it's true, right? That's one of the things I've heard people go, I know all the problems with SOAP, but the one thing I used to like about SOAP is I could just go and point to the WSDL and generate a stub, and I was away and coding against it.
I have other two questions for you. You are such an expert on the API field, so I would like to ask just like your view on this. So one is about let's say API discovery, and maybe we start with that, and then I keep the last one if you have time at the end. That is coming back every 2 or 3 years. This question to me, I'm asking, what is the state of hypermedia and things like this? Does at the end of the day, did hypermedia ever deliver? But let's keep that one maybe if you have time for the last one. So I would like to have your take on API discovery, like APIs, APIs.json. There are some in the market. So it was something maybe very niche. Is having more traction? Yes or no? Is there any other standard for API discovery? So I see the value in combination of an API catalog and these kind of things. And I was wondering, what is your opinion in the API discovery space or problem, let's say?
So the API discovery problem became really visible to us when we took this journey with Kiota, because with Kiota, we're saying, don't go and download a prepackaged SDK from your favorite package manager. Go and generate it from an OpenAPI. Well, we've just moved the discovery problem to now I have to go and discover the OpenAPI description.
Where is it?
Where is it, right? Is it on GitHub? Is it some file that I download from a developer portal? Like how do I go find it? And if you've been around in the API space for a while, you're probably familiar with there is an API's guru site for searching, and it has a few thousand APIs, open API descriptions in it. And we ended up integrating that into the Kiota tooling, so you could go search, and we would search within the API Guru's repo. We also allowed use the GitHub search engine so that you can go and mark a repo with a particular tag and say this thing contains APIs in it, and if you put an APIs.json file, we'll go and search and find that APIs.json. And then go and find the OpenAPI description. So, I mean, APIs.json is a great effort. There has been a reboot of that effort from Ken Lane and Stephen Wilmot to bring APIs.json back, and they have rebooted a search engine. It just has a...
Isn't this such a very niche initiative, the one of Ken Lane, for example?
It's a big problem that needs to get solved. And, you know, yeah, they're making efforts. They put a fairly aggressive rate limiting on their API. So it's a bit difficult to integrate it into tooling. And it's a paid offering because, you know, somebody's got to pay for the cogs. Okay. So there's that effort. And so there are people who are recognizing that it's a problem. There's another effort in the IETF HTTP API working group. We have just finished last call for a new RFC called the API Catalog RFC.
I read that.
Okay.
And I love it.
Okay.
So that's what this is about. I hope that it's coming very soon because this is a very simple thing, but it's lovely. It's
yes.
very useful.
So I wrote up what we call the Shepherd document for that last weekend. And Kevin Smith, who's the author, he took that feedback and he updated the draft. So there's a new draft out this week. We will be discussing that in the IETF meeting that is coming up in 2 weeks. And that should be going for area directorate review, and then IETF last call and IESG review and blah, blah, blah. It's got to go through all of the machinery of the IETF, but that will be getting published in the next 6 months. So yeah, that's a great effort. It leverages a bunch of good stuff.
And to recap for the viewers of this show, it's creating a well-known endpoint like the one of OpenID Connect, so you can find your specification your URI / well-known / API catalog, something like this. So there is a standardization. So if I go to check an API of Massimo, I don't have to spend 10 minutes on his website to try to find the OpenAPI or the specification. 10 minutes on your website, 10 minutes on another website. We might at the end up with a unified URI, depending how you want to see it, to discover your API catalog, right? That's what it's about?
Yeah, well, that is one way of doing it with a well-known URI. There's also a link relation. So if you have a developer portal, you could create a link in there with a link relation to an API catalog so people can discover it that way. So there's a variety of different solutions. It isn't prescriptive of exactly what format needs to be used for the API catalog, but it does recommend to use the link set document, which again allows you to use standardized link relations to point to specification descriptions and things like that. So there's a fair amount of flexibility in it, but there's enough semantics that will allow machine discoverability in order to create that, to be able to allow somebody to build a search engine to start going and discovering those things and making them available. And the other thing that I've been experimenting with, and there's nothing public yet, but I've been taking OpenAPI descriptions and taking the operations and creating vector embeddings and putting them into vector database, and then putting a search engine front end on it so that you can actually ask natural language questions. And then it will go and find you the operation that matches that natural language question based on a nearest neighbor type of index. And it's quite spectacular how good some of the results are. Like you'd be able to ask questions like, what was the score for the Raptors game last night? And it is able to find in the index the API for fantasy data for NBA, because the LLM knows that there's a proximity between the word Raptors and NBA. You can ask all kinds of natural language questions, and it's able to come back with a set of API operations. And this is an interesting thing: is we're indexing at the operation level, not at the API level. And that's where a lot of the interesting information is, insofar as the description of the operation. The URI contains a lot of English language words that help you. The request parameters have information that is useful. So if you have a reasonably well-documented OpenAPI description, it's quite good at finding those operations. And so far, our performance that we've seen has been really quite good. Sub 100 milliseconds type search. I mean, we've only been indexing about 50,000 operations at the moment. But we've been using the Quadrant vector database, and it has the ability to scale up to millions of operations. So that's something that we're going to continue investigating. But we think there's potential for being able to ask natural language questions and get accurate API discovery.
Yeah, that's a very, let's say, interesting use case for the discovery. Yeah.
Yeah.
Okay, that's great. So we are over time, but I'm very curious every now and then about this hypermedia. If ever delivered whatever hypermedia format you like, collection plus JSON, whatever media type. At the end of the day, it was that maturity level, the third, the let's say, looking at the sky, that brings complexity client side. But if you look at the market, at your experience, did you see an adoption of hypermedia, or at the end of the day, simplicity is and the resource based is the one that is still 90% versus 10%? What is your view on this?
So let's qualify. Hypermedia was a phenomenal success for the web browser. Hypermedia APIs has failed miserably to become mainstream. I will claim there are successful hypermedia APIs that people who've put the effort in have been able to actually successfully deploy. I have one myself. I deployed years ago that is still running in production at customers today. But obviously did not make mainstream. I have a hope that we will see a resurgence, but not in the standard APIs that we are used to seeing, because, as you say, it requires a bunch of extra work in the client side, and it is really, the client becomes really dumb with a hypermedia API, and people just don't naturally follow that model? Why am I making a whole bunch of extra work to try and make the client dumb? It's just much easier to just put some intelligence in the client because it knows what it's going to get back from this endpoint. So why make it generic? Well, the one answer to that question is, well, what if you're building a AI-based chat experience that uses an LLM to do natural language understanding, and you want to leverage APIs as grounding data in that AI chat experience? Now you're building a client experience that is generic. And because you're building a plugin model so that you can extend that chat experience, it doesn't know about those APIs beforehand. It doesn't know about the shape of your JSON. And when you start to try and combine API calls together, because one of the things that LLMs are really quite good at is taking a question that a human asks in text and breaking it down into multiple steps. But translating those multiple steps into multiple coordinated API calls is quite difficult. Because one, you've got to match to parameters. And then when you get to the second call, you make a decision as to whether or not you can call that second. And you've got to pass parameters in it. And some of those parameters might be from previous parts of the conversation. They might be from return from the first API that you called. And creating that sequence of calls is hard. If that API that you're calling is a hypermedia API, then all the LLM has to do is figure out which links do I have to follow. And as you follow those links, you're passing data to the service who's going to return more links that can embed some of the previous decisions that you've made into those links. And this gets at that concept of hypermedia as the engine of application state. It's where, as you transition from one link to another, you're aggregating the previous decisions that the user has made and incorporating those into the new links that are presented in the next request. So that challenge of how do you take that natural language question, formulate it into a set of steps, and then make it into a sequence of calls, all of a sudden gets a whole lot easier if the API is returning just affordances that the LLM has to make a decision. Should I pick this link or this link? That's really, and maybe fill in one parameter because of the next question that the user was asked. And so that model fits so much more nicely into the hypermedia world. It will be really interesting to see if somebody picks up on that and actually goes and builds it.
It makes sense that these sort of generative AI use cases are bringing back or giving a second life to a lot of older, not old technologies that are enabled in a different way. That's very, very interesting to see all of this evolution and how potentially those agents as well will behave and how they can leverage these existing technologies.
Yeah.
Okay. Yeah, go ahead.
Everybody looks at LLMs and criticizes, but they hallucinate information. Absolutely. Relying on LLMs to give you answers to questions is just a path to pain, right? You can't control authentication of information. You're not going to have up-to-date information. What LLMs are is right in the title. They're language learning models. They understand language, and that's how we should be using LLMs to be able to understand the user's intent. And I think that chat-based LLM-driven experiences are really our next major user agent. They are a web browser type of capability, where a web browser was a generic client that allowed you to navigate through documents as UI. LLMs are going to power chat-based experiences where you can navigate through an application. And I think they will be as big as web browsers were.
So LLM is the next Google for applications, let's say like this.
Somebody can go build it.
Okay. Okay, Darrel, it was a wonderful chat. Great topics. I like them. So unfortunately, we are at the end of our recording. Otherwise, we will continue for an hour. So I thank you so much for joining our show today. And voila, I want to thank you and thank to everyone that will watch this episode.
Well, thank you for inviting me. It was great chatting.
Nice to see you again. Bye. Thank
Bye.
you.